I think we have completed question number 22. Did we complete question number 22? That 10, or we were doing it? Did we complete question number 22?
Yes, sir.
Okay, now next one. So start with a knot. Knot. Write a knot. Now we go to the next topic, next type. Like this. If a function is defined, differently towards left and right of a particular point, x is equal to a. I will repeat. If a function is defined differently towards left and right of a particular point, x is equal to a, comma, to evaluate limit x tends to a. To evaluate limit x tends to a, we need to take LHL and RHL. What do you mean by LHL? We discussed it earlier.
Left hand limit, right hand limit.
Hand limit and right hand limit.
Left hand limit and right hand limit. So I repeat, see, if a function is defined differently towards left and right of a particular point, x is equal to a, then to evaluate limit x tends to a, we need to find left hand limit and right hand limit. And see that only in this case, we need to find this LHL and RHL. Otherwise, we don't have to waste time. That we'll see in questions. Next line, if LHL is equal to RHL, that means if left hand limit and right hand limits are equal, if LHL is equal to RHL, then the limit exists. Then the limit exists. Otherwise,
Sir, the
limit exists. Exists means there is a particular value. There is a value. Limit exists. Otherwise, the limit does not exist. Otherwise, the limit does not exist. I'll repeat from beginning. If a function is defined differently towards left and right of a particular point, x is equal to a, to evaluate the limit x tends to a, or to evaluate limit at x is equal to a, we need to find left hand limit and right hand limit. And we say that the limit exists only if these two limits are equal. That means if left hand limit and right hand limits are equal, the limit exists. If left hand limit is not equal to right hand limit, then the limit does not exist. That is what we discussed. Now, this one actually, next year also we need this. For evaluating limits, we need this. And most of the time, students used to waste time in finding left hand limit and right hand limit unnecessarily. That means, see that we need to find this LHL and RHL only if it is defined differently. That means if this particular point is a partition point, for example, coming to question number 23. See, question number 23, it's very easy. See this and understand it carefully. A function is given, f of x. See, this function is 2x plus 3. It is given. This function is 2x plus 3 if x is less than or equal to 0. And it is 3 into x plus 1 if x is greater than 0. This is the function given. And we need to find two things. Find two parts are there for the question. First part is to find limit x tends to 0 fx. And second one is to find limit x tends to 1 fx. This is the question. We need to find these two limits. Limit x tends to 0 fx, and see that if it, again, the figure is not a must, but if we draw the figure of this one, we have this number line. In this number line, see how it is defined. Just a rough figure. So 0, 1, 2, 3, minus 1, minus 2. See, the definition of function, if x is less than or equal to 0, so from 0, if x is less than or equal to 0 means towards left of 0. Less than or equal to 0 is this portion. Here, the definition of function is 2x plus 3. If x less than or equal to 0, that means towards left of 0, it is 2x plus 3. Whereas towards right of 0, towards right of 0, x greater than 0 means towards right of 0, the function is defined as 3 into x plus 1. Now, what we wrote it in the note, what we discussed is, if a function is defined differently towards left and right of a particular point. So here you can observe it. This function is defined differently towards left of 0 and right of 0. That means the 0, we can treat this as a partition point. 0 is a partition point because towards left of 0 and right of 0 function is different. In such cases, to evaluate the limit at this partition point, so to evaluate limit x tends to 0, in this case, we need to take left limit and right limit. See, the reason x tends to 0 doesn't mean that x is equal to 0. X is nearer to 0. X is nearer to 0 means left side also it is nearer to 0, right side also it is nearer to 0. But when we take this left side, you can see this function 2x plus 3. Whereas towards right, it is not the same function, it is a different function, 3 into x plus 1. So while applying limit, left side we take this function, right side we take this function. So in this case, at this partition point, we need to take left hand limit and right hand limit separately. So we need to find left. So to evaluate limit x tends to 0, what we do is limit, we write LHL. LHL of limit x tends to 0. To show that this is LHL, we write 0 minus. See, it is not minus 0. This minus or plus we write only to identify or to show that it is left limit and right limit. This one doesn't have any role while substituting the value. So 0 minus fx. 0 minus fx means we are taking the definition of function towards left of 0. So it is limit x tends to 0 minus. And see, left of 0 from figure, we can make it out. What is the definition of function? It is 2x plus 3. Towards left of 0, it is 2x minus 2x plus 3. We know how to evaluate it. Directly substituting 2 into, see that substituting, we will not substitute this minus or plus. It is not minus 0, or even if it is 1, it is not minus 1, it is 1 only. That means the number only. This minus sign significance is shows left hand limit. So 2 into 0 plus 3, which is 3. So we evaluated left hand limit. Coming to right hand limit. Right hand limit is limit x tends to 0 plus we write. See, that is plus or minus sign we write after the number fx. It is limit x tends to 0 plus. Again, the value of fx.
That 3x plus 3.
Towards right of 0, the function definition is 3 into. It is not 2x plus 3. Towards right of 0, you can see here the function is 3 into x plus 1. Left of 0, it is 2x plus 3. Right of 0, because 0 minus means left of 0. 0 plus means right of 0. Right of 0, you can see from the figure, 3 into x plus 1. This is 3 into 0 plus 1. That's also 3. So we got left hand limit and right hand limit equal to 3. This implies, or therefore, this limit x tends to 0 fx will be 3, because left hand limit and right hand limit exist. So remember it, we find this left hand limit and right hand limit only if it's a partition point. It's a partition point means left of that point and right of that point if the function is defined differently. If it is separate definition, then only we need to take left hand limit and right hand limit. Otherwise, don't waste time in finding left hand limit and right hand limit. Now the second bit. Second bit is to evaluate limit x tends to 1 fx. So limit x tends to 1 minus. What is limit x tends to 1 minus? Yes, tell me.
Left hand side 1 minus 1.
What is it?
2x plus 3 limit.
Yes, sir.
Other answer?
The left hand limit, sir.
Sir, x will be 1.
The x will be minus 1.
Very good try, everyone. Very good try.
So no one got the idea. First of all, this is what I said. When do we find left hand limit and right hand limit?
So when it is 0.
In all those previous questions up to 22, we did question number 22. Previously, we did till yesterday. Did we ever find left hand limit and right hand limit in all those previous questions? What we did till yesterday?
No,
Why
sir.
didn't we find left hand limit and right hand limit there? And why did we find left hand limit and right hand limit in this question?
So because in this question there are two functions.
That is what we discussed. If it is a partition point means if the function is defined differently towards left and right, then only we need to go for finding left-hand limit and right-hand limit. Otherwise, no need. It's a waste of time. See, here, the point taken is 1. Did you see that point 1? The point is 1 is here. This is the point 1. You can see 1 here. Now see, what is the definition of function towards left? Towards left doesn't mean that towards left till the infinity. No. Towards left means just left, just right. We call mathematically, we call it as neighborhood. We call it as neighborhood. So here, just left of 1. Just left of 1, what is the definition of function? Function is 3 into x plus 1, is it? Because after 0, the function remains as 3 into x plus 1. So just left of 1 function is 3 into x plus 1. And what is the function just after 1? Just after 1 also function remains the same. That means this 1 is a partition point.
No, sir.
1 is not a partition point. If it is not a partition point, we don't have to find left and right limit. Directly we can find the limit. Limit x tends to 1 fx. Did you get it? Is the idea clear? Here, 1 is not a partition point, or towards just left of 1 and right of 1, function remains the same. So even if you are taking left limit, we need to take 3 into x plus 1. Again, if you are taking right limit, we take the same function 3 into x plus 1. Then why to waste time in taking the same function 2 times? No need. Whereas here, left side of 0 and right side of 0, function was different. It was differently defined. Did you get it? Is the idea clear? Is it clear?
Yes, sir.
So this one, do remember it, next year also we will come across a lot of questions in this one. So Huzaifa, you said that, sir. No, you said IDK. IDK means I don't know. That is what you wrote. Okay, so x tends to 1. See that? We need to find left and right limit only if it's a partition point. Partition point means if left and right side of that particular point functions are different. Left and right doesn't mean that left till the infinity and right till just the neighborhood, just left and just right. So 1 is not a partition point. We can take limit directly. Limit x tends to 1. Fx. Fx remains as 3 into x plus 1. So it is 3 into 1 plus 1. That is 3 into 2, 6 is the answer. So remember it, we take LHL and RHL. We take left hand limit and right hand limit only if the question is to find the limit at that partition point. If the question is to find limit at any other point, we don't have to take left and right limit. Is it clear? Next one, 24th one. Fx. X square minus 1. If x is less than or equal to 1 and minus x square minus 1 if x is greater than 1. Actually, this figure is not necessary. I am drawing the figure just to understand. In examination, no need of drawing figure. So we have 0, 1, 2, 3. Minus 1, minus 2. See, less than or equal to 1. That means from 1. The function is x square minus 1. Whereas towards right of 1, the function is minus x square minus, this is given. Our question is to find limit x tends to 1. The question is to find x tends to 1 fx. Again, do we have to find, the first thing to be thought is, do we need to find LHL and RHL? Do we have to? Yes.
Yes. Yes.
Why do we have to find LHL and RHL?
Partition point here.
Because 1 is a partition point. Towards left of 1 and right of 1, we can see the function is different. See definition, by seeing definition. Figure, it's very clear. Even by seeing definition, we can find it. So in examination, not of drawing figure, but if you're drawing figure, it's okay, no problem. But from this definition itself, we can make it out. 1 is a partition point. That means we need to take LHL. LHL is 1 minus. See that this 1 minus, this minus is not minus 1. We write 1 minus, which shows left hand limit. While substituting the value also, we will not substitute minus 1. If it was minus 1, we should have written minus 1. This is 1 minus. 1 minus means left hand limit is equal to limit x tends to 1 minus. 1 minus fx. ഞാൻ ക്ലാസ്സിലാ പറയും സ്കൂളിലൊക്കെ ഞാൻ ഇപ്പോൾ ക്ലാസ്സിലാണ് 11:30 കഴിയും 11:30 കഴിയും. Yes, sorry. So 1 minus fx means towards left of 1. We can see that towards left of 1, the definition of function is x square minus 1. Now, to evaluate this one, directly substitute it. 1 square minus 1, which is 1 minus 1, 0. This is LHM. Now, a right hand limit. Limit x tends to 1 plus fx. Limit x tends to 1 plus fx. Towards right of 1, see here, towards right of 1, the function is minus x square minus 1. Putting value, minus x square means minus x is 1. 1 square minus 1. It is not minus 1 the whole square, it is minus 1 square. Minus 1 square is, what is minus 1 square? Minus 1 minus.
Minus 1 minus 1 minus 2.
What did you observe here?
So the limit does not exist, sir.
LHL
LHL and RHL
not
are different.
equal to RHL, which implies
Limit doesn't exist.
limit doesn't exist. If LHL and RHL are different, then the limit does not exist. Did you get the idea?
Yes.
So remember it?
Yes, sir.
We
Yes, sir.
find LHL and RHL only if it's a partition point, otherwise not. That's an important thing. And this one, most of you will not take care of this next year while getting the question. In questions where we need to find LHL and RHL, you will take it directly, whereas the questions where we don't need to find, there you will waste time in finding LHL and RHL. Okay, let me take the attendance first. Shahir. think I missed someone. Shahir was, I saw one Shahir there. Now he is not there. Do you have a Shahir in our group?
Yes, sir.
He has gone. His roll number was 30, I think. When I took the attendance, he left. Okay. Now, next one. Next one, 25. Fx. Modulus x by x. X not equal to 0 and 0 if x is equal to 0. Question number 26 also same thing. That's a homework. Exactly same. 26. 27 also you can do by yourself. It is direct substitution. Again, see, modulus questions. Whenever we get modulus questions, do you remember it? Whenever we get modulus questions, the very first thing is redefine modulus question. You learned that in chapter 2. Anyone, do you remember definition of modulus function? This is minus x if x less than 0 is equal to x if x is greater than 0 or greater than or equal to 0. That means modulus function, it takes two values. Towards left of 0, it is minus x, right of 0, x. X not equal to 0 means it can be left of 0, right of 0, is it? So this function, see how we are redefining function? This function, here it is given to x not equal to 0, x equal to 0. So x not equal to 0 means x can be less than 0. So if x is less than 0, see here, it is this modulus x becomes minus x. So this is minus x by x if x is less than 0. If x is less than 0, minus x. This modulus x we wrote as minus x. It is 0 if x is equal to 0 because we are writing in continuous way. First x less than 0, then x equal to 0, then x more than 0. If x is more than 0, modulus x becomes x. So x by x. So we redefine this function. This is redefining this function. See that modulus x we redefined as minus x and x. When is it minus x? If x is less than 0. If x is less than 0, minus x. If x is more than 0, x. Because x not equal to 0 means x can be less than 0 or minus more than 0. Now, as in the previous case, if you are drawing the figure, again I repeat, figure is not a must. So if we draw the figure, we have 0, 1, 2, minus 1, minus 2. Towards left of 0, that means from here. Towards left of 0, it is minus x by x. At 0, it is 0. At 0, it is 0. Towards right, it is x by x. This is the definition given. left of 0, left of 0 minus x by x, right of 0 x by x. Again, the question is to find limit x tends to 0. So first task, x tends to 0, do we have to find left and right limit?
Yes,
or
sir.
yes,
Yes,
because
sir.
left of 0 and right of 0, left of 0, right of 0 function is different. So LHL, limit x tends to 0 minus fx. Limit x tends to 0 minus fx towards left of 0. See, this is minus x by x. It is minus x by x. Again, minus x by x, don't put minus 0 by 0. It is 0 by 0 form. 0 by 0 form, we can simplify it. X tends to 0 minus. If you're simplifying it, what do we get? Minus 1. So it is minus 1. There is no x here, minus 1. If it is 0 by 0 form, we need to simplify it. Now, right hand limit. Limit x tends to 0 plus fx. Limit x tends to 0 plus fx. What is fx towards right of 0? It is
X
x
by
by.
X.
Again,
1.
yeah, we
Limit
cannot
of
substitute 0
1.
by 0 by 0. We
1.
have to simplify it.
Limit
Limit
of 1.
x tends to 0 plus 1. So it will be 1. What can we conclude?
Limit doesn't exist.
Doesn't exist.
L not equal to RHL, which implies limit does not exist. Completed? So today we discuss one thing, finding left hand limit and right hand limit. We find it only at the partition points or if the function is defined differently. That is why up to question number 22, we found it directly because the function remains the same. Function was same. For the same function, no need of taking the same function 2 times. The name of left hand limit and right hand limit. 26, 27 homework. 26 is exactly same. 27 direct substitution. 28 we'll do tomorrow. 29th one, just tell me the answer. It's a homework again. 29th one.
Sir, can you show the previous slide?
What is it?
Previous slide, sir.
Previous? You need this?
Yes,
Take a
sir.
minute. Yes. See, fx is x minus a1, x minus a1, x minus a2, x minus a3, etc., x minus an. The question is to find limit x tends to a1 fx. First thing, do we have to find left hand limit and right hand limit?
No, sir.
No need, because there's no partition, it is only one function. So what is the answer? Up to n, a1, a2, a3, etc., up to n factors are there. What is the answer? Do by yourself. What to do? How will we evaluate this limit? Put x is equal to a1.
A1.
So everywhere
Sir,
a1.
get 0 as the answer.
What is it?
0 will get the answer.
Why 0?
No, it's not 0.
X
It's
A1
not
is
0.
0.
Yeah, but this term becomes 0. So 0 into anything is 0 only. So 0 is the answer. A1 minus A1, A1 minus A2, A1 minus A3, A1 minus A2 is 0. 0 into something is 0. 0 is the answer. That's it. So we'll meet tomorrow. Tomorrow we'll do question number 28. So today's discussion, remember it. Left hand limit, right hand limit. We find it only at the partition point where the function is defined differently on both sides. Okay. Anything else?
Thank you, sir.
Okay. So